All right. So today we have Douwe Kiela. He is CEO and co-founder of Contextual AI, which you can find at contextual.ai. He is also an adjunct professor in symbolic systems at Stanford University. So with that, Douwe, welcome to the podcast.
Thanks for having me.
So today, I guess the big topic is RAG and retrieval-augmented generation in general, but we'll probably cover other topics that are buzzy in AI. But let's start with RAG. So with frontier models now advertising these massive context windows, so I think some are really talking about 10 million context windows. So many developers are wondering, is RAG becoming kind of obsolete in some ways now? So uh, what's your take on these expanding context windows?
Yeah, it's obviously a question I get very often. I get it so often that we now have a blog post up on our website. There's a URL for it as well, isragdeadyet.com. It's usually a good sign if something keeps getting pronounced dead. It usually means that it will never die. I mean, it's a little bit nuanced, right? So these long context models are solving a similar problem to what RAG is solving for, which is how can I get the relevant information into the language model so that it can do its job, right? So the main observation, I think, is that it's just very wasteful to use the full context all the time, right? It's like the example I always like giving is like Harry Potter, and you want to know like who the headmaster is in the Harry Potter books. Like, do you have to read all the books to find the answer to that question? It's very, very wasteful in terms of compute, right? So I think in the real world, these types of dichotomies are rarely true, right? So what will actually work best is RAG plus long context models. You probably don't want to use all 10 million tokens because it's wasteful, but also because the performance degrades, right? There are lots of papers that show that even like the latest Gemini models, the ones that had 2 million token contexts, actually saw performance degrade after 2,000 tokens. So you can cram it all in there, but that doesn't mean that it's going to actually work, right? So the real solution to all of these problems is to use RAG, find as much information as you can that is relevant, put it in the context of the language model, and then it can do its job. So that dichotomy is just not really a real thing. I think one of the main issues maybe that developers are thinking about is that RAG systems are annoying to build. And long context systems are easy, right? You just put it in a context and it takes care of everything. But that's really kind of thinking about the problem in the wrong way, because if you can make RAG easy too, then why not just use RAG, because it's way cheaper and way more efficient than the long context.
And I guess the other thing I'll add in there is, well, a couple of other things. One, the reasoning models even make it worse in terms of cost and latency.
Mhm.
And then secondly, if you're talking about something with a lot of usage, so high repeat, I mean, it doesn't make sense. Maybe if it's a one-off, your Harry Potter example, it's a one-off. I'm only going to ask this once. Maybe you'll try it then. But most people don't build for one-off, right?
Exactly.
So, yeah.
Yeah.
So the other thing that you've been talking about is this notion of RAG 2.0, which seems like in many ways, it seems like it's a natural thing, right? So emphasize systems over models. So I've long warned people that with RAG, it's actually RAG is a complicated system to build, as you mentioned, because there's so many knobs to turn, right?
Yeah.
And very few developers actually have the skills to systematically and principally in a principled way turn those knobs, right? So talk to us about RAG 2.0, and can you unpack what this means practically for teams building AI applications?
Sure. Yeah. So you mentioned it, right? Systems. That's really, I think, the core observation here is that the language model is only a small part of this much bigger system. And if the system doesn't work, then you can have an amazing language model, but it's not going to get the right answer. So if you start from that observation, then it becomes obvious that you should think about RAG as a system where all these model components can be optimized together. So you can do that through machine learning, sort of fancy joint optimization, and that's actually what we do in the original RAG paper. But it can also just mean that you make sure that all the components actually work together, and that the way you do your extraction is actually the way that is optimal for your retriever, and that your retriever and your re-ranker work really well together, and that your language model is really grounded in the things you retrieve. So you can optimize all of these different steps of the RAG pipeline to work well together. And that's really what RAG 2.0 is about. We have to kind of distinguish it from the original RAG because, especially when we were just kind of announcing this, a lot of people were building these Frankenstein RAG solutions, right? It's like off-the-shelf embeddings, off-the-shelf language models, and then just kind of building very brittle systems. So we had to give it a new name to contrast with that.
So it sounds like what you're describing is kind of very similar to what other parts of AI are trying to do, right? So in speech, they have this notion of the end-to-end system.
Yeah,
So
exactly.
it sounds like this is an end-to-end system. So how early in the pipeline is your vision encompassing? So does it start in the information extraction to the embedding to the chunking? So where in the pipeline does it begin?
Yeah, so we have two core concepts. So one is a data store. So that's really the extraction, so document intelligence, document understanding, where we do layout segmentation. We figure out which parts are what type. So like a table and a chart and text, they have different extraction methods. So different models for doing that. And then we collate all of that information, then we chunk it with a machine learned way. So not just arbitrary chunking, but the optimal way to chunk. And then that gets stored in this data store. And then you can have agents or applications, but we call them agents, sit on top of these data stores. And those agents, they do what we call mixture of retrievers. So it's like a smarter way to do retrieval than just kind of vector database standard stuff. And then we have a re-ranker and a grounded language model. So that together is basically the RAG pipeline. So
what about embeddings? Is it also automatically chosen for me? Because if I go to Hugging Face, now there's 10,000 embeddings.
Yeah, but most of them are not great.
Yeah, exactly. Yeah.
So we save you a lot of that effort, basically. So those embeddings are optimized to work with the rest of the pipeline. So it's kind of opinionated orchestration, maybe is a way to think about it. But then, like you said, where all the parts are jointly optimized to work well together.
This sounds actually great because if I were to rewind 2 years ago, when RAG first started becoming more mainstream, a lot of developers and teams were sharing blog posts about, hey, here's our key findings. Mm-hmm. Forget about embeddings, focus on chunking, mm-hmm. right? So, and then basically you had all these rules of thumb and kind of shared stories. But at the end of the day, nothing beats doing it yourself and trying it on your data. But it sounds like this eliminates a lot of that trial and error.
Yeah, that's the idea. Yeah, so we basically have two APIs, one for ingestion and one for querying. And so the query is exactly the same as the OpenAI sort of chat completion API, but then it's contextualized on your data, so the data that you ingested, and it takes care of the whole thing for you.
And by the way, one of the things that is underestimated in RAG in some ways is this document parsing. Mm-hmm. Basically, I think a lot of people over-focus on embedding and chunking.
Yeah.
But honestly,
I don't understand why people make such a big deal out of the chunking.
All you have to do is go to try to find a PDF extraction library for Python. There's so many of them, and you can't tell which ones are good.
Oh, they're all terrible. Yeah. So we have our standalone kind of component APIs, and so our document parser is also available independently. And so one of the things that we found, complex layouts in some sectors like finance, you have extremely complex layouts. And then there's really nothing off the shelf that you can use that would work. So we had to really roll our own solution. We didn't want to do that initially, but we had to do it because nothing else was good enough. And then in our case, since we know that this is going to be used for RAG, we do a bunch of processing on the document already to make sure that it's maximally useful for RAG. So what that means is that we extract not just the raw information in like Markdown or JSON or whatever you want. We actually, alongside that, extract the document hierarchy. And that's really important. So let's say you have a paper, you want to understand, oh, this is a part of the introduction, this is a part of the methods, this is a part of the results. And so that information is extremely relevant as metadata when you're doing the retrieval. Right. So again, back to this like RAG 2.0 point, it's like if all the parts are really jointly optimized for RAG, then you just get much better RAG systems.
So I'm channeling listeners who might be wanting me to push back, which I'm not, but I will anyway.
Sure.
So people might say that so there's open source libraries. I don't know. I'm just going to rattle off a bunch of them: Docling, DocETL, Aaron, and Sycamore. So I'm assuming, as you mentioned, you didn't want to build this yourself. So what prompted you to build your own document extraction, which I assume also encompasses OCR, right?
It encompasses OCR. It has VLMs in there, complex layout segmentation, different extraction models for different modalities, detection of document hierarchy. So it's really a very complex. That in itself is a very complex system, right?
And then I'm assuming you kick the tires on a lot of these open source projects.
Yeah. So we tried lots of different things, and it just wasn't really good enough for what we wanted, and especially not for the kind of RAG problems that we're trying to solve, right? So we're always looking to have it scale at huge scale, millions of PDFs with complex layouts, and then making sure that you have very high accuracy and that you also have a little bit of control over what actually goes into that system. And so the open source things are great for just getting started, right? But like I always tell people, you need to build for production. Don't build for the demo, right? Because there's a huge gap between the demo and actually productizing AI. And so we see a lot of people go like, oh, there's a great like 5 documents. I can do everything myself. It's easy. It works. And then you show that to the CEO and he goes, okay, we're going to use this thing now. Make it work on 1 million PDFs and like a real use case, noisy data that's all over the place, conflicts. And then it becomes really, really hard to actually get it to work, right? So we see a lot of projects kind of die on the way to productization, and that's something that we want to help people avoid.
By the way, as you alluded to, it's not just a question of information extraction, because there's structure inside these documents that you can leverage, right? So like you said, hierarchy, metadata, all of these things, right? So
Yeah.
And as you mentioned, so a lot of people early on their big takeaway is don't focus on embeddings, focus on chunking. But my intuition always said was, well, actually the information extraction, because if you can't extract the information, what are you going to chunk?
Exactly. So it's all like it's all dependent, right? It's a causal. So if your information extraction is bad, you can chunk all you want, but it's not going to do anything. And then if that's bad, then you can embed all you want, but that's not going to do anything, and etc. Right? So the language model is really just the final piece where the performance compounds. So like some people like at Databricks, for example, they call this compound systems, right? Where it's really like the performance compounds or cascades across the different components. And so if the one at the beginning is bad, there's really not much you can do to recover it. So I think you're totally right. That's very important.
Thank you for the shout out to Databricks. I'm an advisor. But
Nice.
So what are you using for scale, Ray?
So we are not using Ray, no. For scale, we are just using our own systems. So everything is Kubernetes under the hood. So
you should definitely use Ray. I'm an advisor to Anyscale.
You're an advisor to many good companies, yeah.
Let's see. So when you're in this early part of the pipeline, what structures are you looking for? So you mentioned hierarchy. So the other thing that people are excited about now, Douwe, are knowledge graphs.
Yeah.
So are you able to extract graphical information out of the documents?
Yeah. So I think GraphRag is a very interesting concept What fascinates me is that I don't understand who is doing the marketing behind this, but that person is very good at their job.
Neo4j.
Emil is amazing.
Yeah.
So Neo4j is a really incredible company. But so in our experience, it doesn't make a huge difference if you do graph rag the way that the original kind of paper proposes, which is essentially is just data augmentation. Right, so they're basically saying, okay, I'm going to add more chunks to my standard vector database that capture some of the hierarchical information. Then I just do standard retrieval. So that's kind of, people call that graphs, but it's not really graph, right? So then what you do with Neo4j is you would generate queries in a query language, which is basically the same as text to SQL. Right, it's not even really sort of
I guess except that if you had a decent so I guess it presupposes you have a decent knowledge graph.
It presupposes you have a decent knowledge graph and that you have a decent text to query language module, and then but that's structured rags, like structured retrieval. It's not really unstructured. You have to first turn the unstructured data into structured data, and then you can do that thing on top, right?
And the problem is most people don't have a decent knowledge graph.
Yeah.
Right. And all right. So then the other thing that I wanted to talk to you about is retrieval itself, right? So early on, everyone was going, we got to go hybrid, right? So BM25 plus neural information retrieval. So where are we now on is retrieval still a big deal once you do all of the fancy things that you did early in the pipeline?
It's still, I think, it's the hard problem, I think, really. And so the way we solve it is still using hybrid. I mean, it's kind of what I call mixture of retrievers, right? So graph rag could be one of the retrieval modalities, and so can text to SQL and other things. You basically have different retrieval modalities that you can choose based on the query and based on what you know about the data. Then you get your initial information in. And ideally, at the first stage, you want to cast a wide net because you don't really know what you're looking for. So you want to kind of do query expansion, query reformulation, make sure that you find all the possible candidates. And then what you do with that is you put that into the re-ranker, or it can even be a cascade of re-rankers. And those re-rankers actually do all the smart stuff because you can't really scale the first step, right? If you have millions of PDFs and that's tons of information, you can't have a very smart model do that because that's going to take a long time. So you want to cascade your retrieval, do fast first stage retrieval, then do re-ranking after that. And so one of the things that we found makes a big difference is the ability to give your re-ranker instructions. So just like with a normal language model, where you can tell the language model what you want and it will follow it, you can tell the re-ranker what you want and it will follow it. So you can tell it like, okay, I want to prioritize like recency. It's very important for my company to have the most recent document. If there is kind of a data conflict, then I prefer this data source over that one. If the CEO wrote it, it must be more important than if it's from an intern. And so you can have these kind of data hierarchies, which are really important in an enterprise setting, especially where data is so messy that you need to have some rules that capture how you actually want to rank data in your systems.
So it sounds like your retrieval step is quite complex. So a couple of questions. One, latency. How does it impact latency? And two, how does it impact explainability and transparency in case something happens and I need to do some debugging?
Yeah, so all of these stages, you just have observability on, right? That's really one of the core things in RAG systems is that you understand sort of what's happening every step. And then in terms of latency, because you kind of narrow the funnel over time, it's not actually that bad, right? So there obviously are trade-offs, like re-ranking doesn't come for free. But if you re-rank only 1,000 documents with a smarter model, maybe that's an acceptable trade-off to make. So the latency is just one of the many parameters that govern kind of the behavior of the system.
So one of the things that I guess a lot of people don't seem to understand is RAG does not completely shield you away from hallucination, right? So in the following sense, right? So you can give the language model in the context window all the relevant information, but the language model might still be opinionated because
Yeah,
it thinks it knows more than you because of some pre-training data that it saw, right?
yeah.
So, what's your solution to hallucination?
Nice. I mean, you're just like letting me give my whole sales pitch here. I appreciate that. So that
No,
uh,
no, these happen to be the topics I'm interested in. Yeah.
yeah, no, I mean it's great. Me too.
Yeah.
So happy to talk about that. So um, you're exactly right. So a general purpose language model needs to satisfy many different constraints. So it also needs to be useful for the marketing department where they're doing creative writing, or maybe you want to use it to brainstorm something, which means that it actually needs to be able to hallucinate, in the sense that it needs to be able to talk about things that are not in the ground truth context. Um, if you have a RAG problem, you really don't want that, because you just want it to be grounded in the context. Whatever you retrieve, that's the context, that's the ground truth, and that's what it can answer on top of. So what we have done is we've taken open source base models and then trained them to be very strongly grounded in the context only. So our model is very, very good at saying, I don't know. And that's really important, right? Because you essentially just want to say the language model cannot talk about anything that it doesn't have any context on. And so we called it our grounded language model, or GLM. It's also available as a separate component. And that really helps a lot with hallucinations.
So the two things that happen as far as the foundation models in recent months: one, reasoning; the second is multimodality. So, talk to me about the implications of both of those for what you're building or RAG in general.
Yeah, I think both are super important for RAG in general. I'm very happy that multimodality is finally getting the attention it deserves. So I wrote my PhD thesis on multimodality originally before any of this stuff, really. And it was actually a part of the inspiration for RAG at the time was grounding. And we were already grounding multimodally at the time, sort of before all of this AI hype and revolution. So multimodality is really important, I think, if you want to get these systems to work on any kind of data. A lot of data is multimodal. A lot
Yeah,
is
why can't you do RAG on videos, right?
yeah, exactly. Or like even just like complex layouts, and like we have Qualcomm is one of our customers, and I really love the story because the data is so incredibly complicated. There's like circuit diagrams and code and all kinds of like tables, and so it's highly multimodal, very difficult content. And so to our earlier discussion, right, you need to extract the information in the right way, and then you need to make sure that the whole pipeline actually works on top of that. So that's really important. And then reasoning, obviously, I think people are still underestimating how much of a paradigm shift test time compute is. This is really going to change everything. And so we are doing a lot of work on sort of domain agnostic planners, and making sure that you have these agentic abilities where you can decide from the reasoning system what you want to retrieve, how you want to retrieve it. Based on what you retrieved, maybe you want to do some more things. So RAG really just becomes one of the tools for this domain agnostic planner to execute on his plan so that it can achieve the results that it needs. So retrieval, obviously, that is the way that you make these systems work on top of your data, and that's really where we want to focus.
So, as you mentioned, inference time compute, right? So, obviously, it'll be slower and more expensive.
Mhm.
So, do you have, so right now, is your system engineered so that you only use that when you need to?
So we are a platform where people can build their own agents, right? An application, so you can choose what you want. So we have think mode where you can use think mode and just say, okay, I want to use the fancy reasoning model, or you can have normal RAG mode, and then it's just doing standard RAG with lower latency. But what's interesting, I think, about latency is that with these reasoning models, people seem to become much more relaxed about latency constraints. So it just depends on how you want to deploy it. If it's real time, then obviously you need to think about latency. In many other cases, it's okay if you can like go away and grab a cup of coffee and come back to a perfect answer. Like maybe that's worth it. So it's just a trade-off you have to make.
So, you describe a system that's kind of optimized end to end, and s- and so all the all the key pieces are tightly integrated. So to me, kind of that implies, and I'm not sure if this is accurate now, but it implies that I don't need to do any fine tuning anymore.
Yeah. I mean, you don't have to, but you can if you want. So we're really
What fine tuning by me at this point? Because basically, you optimize the extraction, the chunking, the embedding, the retrieval. I don't, and then I mean, if I do some fine tuning, I think the ROI would be so small.
it depends, right? So it depends on how much a few extra percent of performance is worth to you. And so for some of our customers, that could be a huge difference in terms of the value, or whether you pass the production bar or not, or whether your sort of model risk and compliance people are okay with you deploying it. Like those few percentages can actually make a big difference in those types of scenarios. So I think fine tuning is actually another case uh, of the false dichotomy. So we also covered that in the isragdeadyet.com blog post, where in the early days of RAG, people were saying, do I do RAG or do I do fine tuning? And so the answer has always been both.
Both, yeah.
And it's the same with long context, and like MCP is the other one. Is like the answer is like everything. Do all the things to make
But
it better.
but I guess so. Let me change the question. My suspicion is with your system, I'm going to do less fine tuning.
Yeah, so out of the box, our system will be pretty good. But we do often help our customers squeeze out max performance, and so that does involve fine tuning of the embedding models, of the reranker, and of the generator. So it really depends on the
And
customer.
and those still kind of fit into the same kind of UX as supervised fine tuning in the sense that here's some examples, here's a few labeled, here's some labeled examples, and then that's it. That's all I need to supply you.
Yeah, exactly. So we don't need that many. So it's not really labels. It's more like examples of the type of behavior that you want. And then what we do is we use synthetic data pipelines to expand so that we get a good enough training set, and then we jointly train the components to work on that. So we're seeing pretty good gains with that on some of the harder problems. It's really about capturing the domain better, but you can see 10, 20% improvement gains from doing that the right way. So that's one of the services we do. It's very hard to generalize that to any type of data. So we're still that's work in progress, basically.
So I opened this by saying I don't need RAG because I have this massive context windows. So here's another question for is RAG dead yet? Which is I don't need RAG because I have agents. So the classic agent example right now is these deep research tools. Aren't they doing what a RAG system is supposed to do now?
They're using RAG under the hood, right? I always get very confused when people ask me like, is it RAG or MCP? I'm like, MCP, you would be using RAG
Yeah.
with MCP, right? MCP is just a communication
It's a
protocol.
protocol. It's just a protocol.
Yeah.
It's not a
So I think
solution.
people who say that they don't really get it. They need to do a bit more reading, maybe. So MCP is great. I think it's an awesome idea to make sure that we have a standardized way for language model to call tools. And so one of the most powerful tools that you can use if you want to make a language model work on your data is retrieval.
So these deep research tools, of which there are many. I mean, Google has one, obviously OpenAI, uh, and a bunch of other players. But the idea there is that the agent is supposed to go out and find the relevant sources for me. It could be using search. It could be querying a database, whatever, right? So in other words, it's doing what a RAG system is supposed to do, but it's not called RAG.
Yeah, I think it's still. But obviously I'm biased, but I would still call that RAG. I mean, one of the tools that is using is retrieval. So
Yeah.
and the agent is the generator, the G, right? So you are augmenting the G with the R. So it's
I mean,
basically
whatever tool it uses, it will retrieve information,
yeah, and
right?
then
So,
the results of that are used to augment the generation, right? So, but maybe I'm kind of rewriting history here. I don't want to sort of like overclaim what RAG is or isn't. It doesn't really matter. But I feel like if you want to get these systems to work on top of your data, then you need retrieval. And so that's really what RAG is
Well,
about.
I guess the main difference now is the end product, right? So because I think a lot of people use this to generate a report or a slide deck that they can edit, right?
Yeah,
So so maybe that it's just a
but that's
UX thing
the
at the end,
difference.
right?
So isn't the difference there just test time compute, basically the fact that we have this ability to do active retrieval rather than passive retrieval? I think that's really the big the crux of it all, right? So in standard RAG, like naive old school RAG, you always retrieve. So you get a query and then you go and retrieve. Maybe you do some query reformulation, you get some results, and you do your complex pipeline, but you still always retrieve. And so you can make that more active by saying, okay, I'm going to first decide from the model if I'm going to retrieve or not. But then with these test time reasoning models, what you can do is say, I can just decide when I want to retrieve and what I want to retrieve based on what I'm currently doing. But you're still retrieving, right? And so that's really what matters most is how you contextualize these models.
So there is a class of agents that don't retrieve. They do, right? So, but they actually don't work yet.
But
The,
one of the things
but
that
the vision is, I can go to an agent and say, "Hey, I'm Ben Lorica.
one of
Find me a restaurant in Toledo, Ohio, based on what you know, but based on what you know from me, and then reserve that restaurant for 4 people."
the,
They don't work, but that's the vision of an agent moving forward, right?
I mean, it's starting to work. I think when you specialize these systems, you can get quite far already now. But so the tool used there in the example you mentioned. So one tool is basically
Retrieval.
retrieval, and then the other is like calling an API, right?
Yeah.
And so the retrieval one can actually also be calling an API. So in the end, like what these planner models are doing, or what these reasoners are doing, is just they have APIs that they can call as tools, and so MCP makes that easier to do. But yeah, so it's just
So at the end of the day, the original vision of Google is still what matters, which is organize all of the world's information, right?
yeah, exactly. But what's really a key difference between the old approach and the newer approach is that we have the G in the first place, that we have the generative answers, right? But because before, I mean, search is very old, right? So we've had retrieval for a long time. What's nice now is that we don't have to reason over the retrievals ourselves anymore. We don't have to scroll through the 10 blue links and figure it out. AI does it for us, and it gives us the whole answer package in the way that we want it. And that's really powerful.
So I'd be remiss if I don't ask you this question, but what parts, if any, of your platform are open source?
So we've open sourced some of our earlier work, and we've published a lot of research. So we're more kind of open research than open source, I think. But a lot of our work on how to do reinforcement learning from human feedback better, or how to evaluate language model outputs in a much more fine-grained way. So we publish a lot of our research to make sure that people can benefit from that too.
By the way, in closing, one of the topics I'm closely watching is I think supervised fine tuning is a solved problem in the following sense, right? So there's so many services. There's a lot of services where all you have to do is upload data and then you go to lunch and then you come back, the model's fine tuned. But I think reinforcement fine tuning,
Mm-hmm.
which applies to reasoning models, there's still a UX problem there.
Mm-hmm.
What's the right way to interact with a domain expert
Yeah.
in order for them to help you fine tune a reasoning enhanced model?
Yeah. So feedback and collecting that feedback is really important. So we do that as a part of our system, and then you can train these sort of dynamic query paths using the reinforcement signal that you get. By the way, on the topic of open source, we do have things like OMOE open source that we did together with the Allen Institute, which is the current best fully open source mixture of experts model, just to give you an example. But that's kind of outside of our standard stack.
So, in closing, in the next 6 to 12 months, that will be a lifetime in this space, right? So, if what would you like to see from the foundation model builders? What are the things that you are chomping at the bit for them to deliver?
I think it would be nice if longer context actually worked. That would make my life easier too. You still need RAG, right? If you have millions of PDFs, then you don't want to put them in the context anyway. But then if you can put more in the context and make sure that it actually gets picked up on, I think that would really help a lot. And I think the other thing, so VLMs are really good, but they're still not great. And especially when it comes to like fine-grained chart understanding, for example, and knowing exactly like this is the value for this particular thing, that's still very nascent. So there's a lot of work that needs to be done there.
So is your platform bring your own model, or you have your own models that you can supply?
But so we have our own models for the entire kind of retrieval and contextualization stack. But for the language model, you can bring your own. But we often find that the GLM we mentioned works better than what you can bring yourself. So we have flexibility, but our own model is pretty good there too.
So are you seeing adoption now of the Chinese models?
Um, yes and no. I mean, they're very good models. I think DeepSeek was just a very important existence proof.
I think there's some hesitation in enterprise still, as far as I don't know
Yeah,
why, around security or whatever, right? So
yeah. So we don't deploy those for production customers, but we do use them in our research.
and with that, you can follow Douwe's work at contextual.ai. And thank you, Douwe.
Thanks for having me.